Did you know that India receives the world's highest rainfall in Mausinram, a village in its Meghalaya state? Intriguing, isn't it? Welcome, brothers and sisters, to the journey of quest where we quench your thirst for knowledge, making you drench in the downpour of awareness and intellect. Today, we're delving into the enchanting world of India's precipitation patterns. A land renowned for its diverse climate and topography, India experiences an annual average rainfall of approximately 1,197 millimeters. However, India's climate is not just confined to intense summers or biting winters. In the inner space, the monsoon winds play their part, sweeping across the land and transforming the terrain into a verdant spectacle. This isn't a uniform phenomenon, though. The country's distinctive geography, marked by soaring mountain ranges, expansive plains, and extensive coastal regions, causes significant variations in rainfall. For instance, Meghalaya, a region nestled amidst mountains, receives an astounding 11,000 millimeters of rain annually. Conversely, the arid Thar Desert must make do with a scant 200 millimeters. Such disparities in precipitation profoundly shape the lives of the inhabitants and the national economy. So, are you ready to plunge into an exploration of the Indian monsoons and the elements that govern the varying distribution of rainfall across the country? Stay with us. India's precipitation pattern varies significantly from region to region, reflecting the impact of its diverse geographical landscape on rainfall distribution. Let's first look at the coastal regions. Located adjacent to the expansive Indian Ocean and the Arabian Sea, these areas are the first to encounter the moisture-laden monsoon winds, resulting in a considerable amount of rainfall. For instance, Cherrapunji and Mausinram in Meghalaya are known to be the wettest places on Earth due to their geographical proximity to the ocean, receiving over 11 meters of rainfall annually. As we move towards the interiors, the rainfall decreases. This can be attributed to the fact that the monsoon winds gradually lose their moisture content as they journey inland. An example of this pattern can be seen in the Deccan Plateau nestled between the Western and Ghats. The plateau receives moderate rainfall and primarily depends on the retreating monsoons during October and November for its annual precipitation. On the extreme side of the spectrum is the Thar Desert in the northwest, which lies within the rain shadow area of the Aravalli Range. The geographical location of this region obstructs the monsoon winds from reaching it, thereby resulting in arid conditions and annual average rainfall of less than 25 centimeters. Contrastingly, the Himalayas, the northern frontier of India, showcase a different precipitation pattern entirely. The western Himalayas receive heavy snowfall owing to western disturbances during winters, while the eastern and central parts experience rainfall throughout the year thanks to their unique geographical location and climatic conditions. In summary, India's diverse geographical landscape plays a crucial role in the distribution of precipitation. The coastal regions receive heavy rainfall due to the monsoon winds from the ocean. The interiors receive moderate rainfall as the monsoons lose their moisture while moving inland. Arid conditions prevail in the desert due to its location in the rain shadow area, and the Himalayas witness both rainfall and snowfall based on their geographical positioning. Thus, the impact of geographical location on rainfall distribution in India is both fascinating and complex. Are you familiar with the term Western Disturbances? Let's delve into what these disturbances are and their influence on the Indian climate. Within the field of meteorology, Western disturbances are weather events that originate over the Mediterranean Sea. They have been given this name because they move towards the east, affecting India and Pakistan, driven by the westerly winds found in the upper tiers of the atmosphere. You might be wondering, how does a weather system birthed so far away impact the climate of India? These western disturbances contribute heavily to the winter rainfall in the northern and northwestern regions of India. The moisture in these weather systems comes from the Mediterranean Sea, the Caspian Sea, and even the Atlantic Ocean. As these disturbances traverse vast land areas and mountain ranges like the Hindu Kush and the Himalayas, they bring with them precipitation in both rain and snow forms. This precipitation is a crucial part of the region's ecosystem, refilling water reservoirs and ensuring the well-being of agriculture, especially winter crops such as wheat and mustard. But it doesn't stop there. These disturbances significantly affect the overall climatic conditions as well. When a western disturbance strikes, it results in a sudden shift in temperature. It feels as though winter has decided to make a grand, dramatic entry, accompanying chilly winds and foggy mornings. In actuality, these disturbances are the primary cause behind the harsh cold waves that frequently pass over the North Indian plains. But what's their effect on the rest of India? Although the impact of these disturbances lessens as we move southwards, they do have an effect on the winter temperatures of central India, and occasionally also influence weather in eastern India. Hence, next time you experience snowfall in the northern plains of India, bear in mind to appreciate the western disturbances. These weather world's overlooked champions play a vital role in molding the Indian climate, defining our winters. From the foggy mornings to the snug winter nights, everything is part of the fascinating meteorological tale woven by these western disturbances. Let's delve into the concept of severe local convective systems and their significant role in the distribution of precipitation. Picture a pot of water being heated on a stove. The water at the bottom warms up, rises to the top, cools down, and then falls back down. This cycle, known as convection, happens in our atmosphere but with air instead of water. When the heat's up, it warms the air above it, causing air to rise, cool down, and potentially form clouds, which can lead to rainfall. This phenomenon, when it occurs locally with high intensity, is what we term a severe local convective system. These systems have a significant influence on precipitation distribution in India, being highly localized and often linked to specific meteorological conditions. Due to localized nature, they can result in heavy rainfall in one area while leaving a neighboring area completely dry. At this point, you might question their role in the distribution of precipitation across India. They are key players in the generation of thunderstorms and hailstorms. When moist air rises swiftly within a severe local convective system, it can lead to the formation of thunderclouds. These thunderclouds can result in heavy rainfall and occasionally hail, both of which contribute significantly to the overall regional precipitation. These systems are not season or region specific. They occur all year round and across the country, from the expansive northern plains to the southern coastal regions. This makes them a consistent and crucial part of India's precipitation patterns. However, the story isn't all rosy. While these systems are indispensable for rainfall, they can also trigger severe weather events such as thunderstorms and hailstorms, leading to flooding and other forms of devastation. So there's a catch. While these systems can wreak some havoc, they are nonetheless vital to India's precipitation patterns. In recapping our journey through India's precipitation, we have three key takeaways. First, we explored the diverse precipitation patterns across India. The rain's distribution fluctuates greatly, with the western coast and northeastern states experiencing heavy monsoons and the northwestern and interior areas receiving lesser amounts. Secondly, we examined Western disturbances, a weather phenomenon originating from the Mediterranean that brings winter rains to the northwestern parts of India. They are especially critical in regions like Punjab, Haryana, and Rajasthan, where they often serve as the main source of winter rainfall. Lastly, we delved into severe local convective systems, localized weather systems marked by intense thunderstorms and heavy rainfall. They primarily occur in pre-monsoon and post-monsoon, majorly affecting rain amounts in central and eastern India. These factors, the monsoons, western disturbances, and severe local convective systems, interweave to form a complex climatic tapestry across India. They shape India's topography, ecology, agricultural prospects, water resources, and disaster management plans. Remember, they're not isolated events, but part of an interconnected global weather system. Lastly, human understanding and interpretation of these patterns have direct implications for daily life and weather predictions. Understanding these factors better equips us to navigate and appreciate our complex climate. Each raindrop, after all, tells its own story. Embarking on the captivating journey through India's rain patterns, it's vital to delve into a key factor, the Indian Ocean Dipole. Often called the Indian Niño, this phenomenon hinges on the temperature contrast between the western and eastern regions of the Indian Ocean. Intriguingly, this dipole exerts an influential effect on India's monsoon rainfall. The Indian Ocean Dipole toggles between two states, positive and negative. During the positive phase, the western section of the Indian Ocean heats up more than its eastern counterpart, which in turn amplifies the monsoon rains by intensifying the moisture-rich winds blowing towards India. On the flip side, in the negative phase, the eastern part of the Indian Ocean is warmer, resulting in the diversion of moisture-laden winds from India, thus diminishing the monsoon rains. But the Indian Ocean dipole's influence extends beyond the monsoons. This oceanic phenomenon significantly impacts extreme weather events like floods and droughts. For instance, a robust positive phase may trigger torrential rains and flooding, while an intense negative phase can induce severe droughts. Thus, despite being thousands of kilometers away, the Indian Ocean dipole has a profound effect on India's rainfall patterns. This underlines the intricate interplay within our global weather system. From monsoons to Western disturbances, severe local convective systems, and the Indian Ocean dipole, these factors interweave to form the complex, ever-evolving mosaic India's climate. Comprehending these patterns is fundamental for resourceful water management, strategic agricultural planning, and preparation for extreme weather conditions. So, the next time you relish a rain shower, remember, each raindrop tells a tale of winds, oceans, and temperature shifts occurring thousands of kilometers away. Let's introduce and delve into the El Niño Southern Oscillation (ENSO) cycle, a natural climate cycle that significantly influences global weather patterns. The ENSO cycle comprises two key phases, El Niño and La Niña. El Niño, translating to the little boy in Spanish, denotes periods of above-average sea surface temperatures in the central and eastern Pacific Ocean. This warm phase of the ENSO cycle has a profound impact on the global climate, altering rainfall patterns and even leading to extreme weather events. Conversely, La Niña, or the little girl, signifies periods of below-average sea surface temperatures in these regions. As the cool phase of the ENSO cycle, La Niña, just like its counterpart El Niño, influences global weather patterns, albeit in diverse ways. The ENSO cycle, with its alternating warm El Niño and cool La Niña phases, is a critical driver of global climate patterns. It shapes everything from the intensity of monsoons to frequency of droughts and floods across the globe. Indeed, this cycle plays a pivotal role in our planet's intricate climate system. Now, let's discuss how these phenomena affect weather patterns on a global scale. Intrigued by how Pacific Ocean phenomena could exert influence over India's monsoon? Let's deep dive into the subject. The key players here are El Niño and La Niña, integral components of a natural climate rhythm known as the El Niño Southern Oscillation, ENSO cycle. El Niño, Spanish for the little boy, represents periods of above-average sea surface temperatures in the central and eastern Pacific Ocean. On the other hand, La Niña, or the little girl, represents periods when the sea surface temperatures are below average in these same regions. So, how do these oceanic events impact the Indian monsoon, you might wonder? During an El Niño year, the heated Pacific waters cause a repositioning in atmospheric circulation, often leading to drought-like scenarios in India. The monsoon winds weaken and the rainfall is below average, triggering a myriad of problems such as water shortages, crop failures, and more. Conversely, in a La Niña year, the cooling Pacific waters instigate a different atmospheric circulation shift, typically leading to above-average rainfall in India. The monsoon winds bolster, bringing in plentiful rains, which can, unfortunately, also lead to complications like flooding. Hence, the interaction of El Niño and La Niña in the Pacific Ocean markedly impacts the cadence of the Indian monsoon. This demonstrates yet again the intricate and interconnected nature of our globe's climate system. As our comprehensive review of India's precipitation patterns reaches its finale, let's take a pause to recollect the key players we discovered on this meteorological journey. We've dissected the crucial elements such as Western disturbances, severe local convective systems, and the dynamic triad of the Indian Ocean dipole, El Niño, and La Niña. Each piece fits into the grand puzzle of India's monsoon performance, creating the myriad rainfall patterns seen across the country. Our journey was driven by more than just curiosity. It was our diligence to equip ourselves with an essential understanding for superior weather forecasting, agricultural planning, and adapting to the ever-changing climate. We've seen how each wind shift, ocean temperature change, and weather event paints a fresh stroke in the saga of a raindrop. Our hope is that this in-depth discussion has sparked curiosity in you for the enchanting world of meteorology. As we dig deeper into our planet's climate conundrums, we extend an invitation for you to join us on this insightful journey. Remember, understanding is the foundation of adaptation and resilience in the face of our shifting climate. So keep seeking knowledge and never cease exploring. As we conclude, let's take a moment to appreciate the magnificence of nature's orchestra, where each instrument plays a part in creating the monsoon melody. Until our paths cross again, stay curious and continue your exploration of the planet's weather symphony. Thank you for journeying along with us through this video. We hope it sparked your curiosity and fed your hunger for knowledge. Don't forget to subscribe to our YouTube channel and hit the bell icon to stay updated with our latest uploads. We end this session with a question to ponder on. What would you do differently after learning about this topic? Stay curious, keep learning, and let's continue this journey of discovery together.